Okay, we're recording. This is a very simple idea that we use in diagrams for trigonometry problems a lot. The angle of elevation is, I'll put this in words, always measured upwards from a horizontal line. So that would mean the angle of elevation is this angle in here. Remember, we learned yesterday that the symbol we use when we're doing this usually is theta. Question? Oh, were you not here when I handed these out? It's not a worksheet, it's the notes package. You must have missed a day. There you go. Okay. So I might even put a little arrow here to, if my pen would work, I could put a little, there we go. Put a little arrow here. Up from the angle of elevation. Okay? Angle of depression is always measured downward from a horizontal line. So that way. And let's take a look at a couple of word problems or word situations that have these new phrases in them here. A cat is stuck in a tree. You lean a ladder against the tree in an attempt to rescue the cat. The angle of elevation formed is 65 degrees. So where is that on this picture? It's right here. This is the 65 degrees. So I usually simplify my diagram. I mean, if I get a real world picture, I just tend to redraw it. So that's the 65 degrees from there to there. And of course, you assume the tree grows straight out of the ground and it's a right angle. And what else can we put on this picture? The top of the ladder reaches 24 feet up the tree. So which of the lines did I draw gets the 24? This one. Right? It reaches 24 up the tree. The ladder itself is not 24. The ladder would be considerably longer than 24. Right? Okay, example 2. Standing on top of a 300-meter cliff, the angle of depression of a boat in the water below is 26 degrees. So I would draw a cliff. Draw a cliff. I draw me standing on the cliff. Ooh, I'm standing on a cliff. And there's water underneath. And it's shark infested. You can have a lot of fun with these. And there is a, what am I drawing it to? A boat in the water. There you go. Boat on the water. There. And what do I mean by angle of depression? Well, if I draw the line where I can see to the boat, like that, where's the angle of depression? You're probably thinking, oh, isn't it this angle right here? No, it isn't. Is that angle, look at the definition. Is that angle measured between a horizontal line downward? No. The angle of depression would actually be the angle between this imaginary horizontal line and my sight line. And you're probably thinking to yourself, you're thinking, self, what good would that angle be? It's not even in the triangle you drew. Actually, it is. Because you know what angle would have to be the same as this angle up here? Would be this angle down here. They'd have to be the same. Can you see why they'd have to be the same? Because the water is a straight line. This is a horizontal, it's a straight line. And this is actually any two parallel lines that are crossed by a line have interior alternate angles that are the same. So these are the interior alternate angles of straight lines. They used to make you memorize stuff like that. I think it's just important that you understand that, how about this? The angle of depression for the observer, that's an R and then a V, observer, on the cliff is equal to the angle of elevation at the boat, right? If you were on the boat looking up at me standing on the cliff, your angle of elevation is the same as my angle of depression, which makes logical sense. We have to look at the same angle to see each other. So there we go. And yes, those of you who are double dipping who have done the essential course, you've seen these concepts before. For everybody else, it might be new. Although, if you did a little bit of similar triangles in grade 9, sometimes they'll set up similar triangle problems and say angle of elevation, angle of depression. So it might not be new to just you non-essential types. But there you go. That's an important definition moving forward. I'm going to just take a little bit of a break from the booklet for a second and get you to think about your geometry set. Remember your geometry set? Remember in elementary, every year in June, they'd give you the shopping list, your class list for the next year. And every year it said, bring a geometry set. So every year you went out and bought one, and probably never used the darn thing ever the next year, but you bought one. What did it come with? What was in the geometry set? Well, there was the protractor, right, the thing that measures angles. There was the compass. Sometimes it had two compasses. One that just had 2 points, and one that had a point end and a pencil side. Right? That's for drawing circles and angles. Then it usually had a ruler. And then, did it have, where are they? Hang on, did I already pass them? Hang on, I thought I put them on this page here someplace. Did it have, hang on, where are they? There they are. Did it have these triangles on them? Remember those from your geometry set? Now, of all of the types of triangles you could throw in a geometry set, why do they all have these two? What is special about these triangles? Any idea? Why are they special? What's the same about them? What do they have in common? They both have right angles. They're both right triangles. Let's use our fancy words from elementary. One of them is scalene and one of them is isosceles. Ooh, anybody remember those words? Which one's which? The one on the left is isosceles. You are right. The one on the left is isosceles. And what that means is this line is the same as that line. You know what that would mean? That would mean that this angle is the same as this angle. Right? How big would those angles be? Well, don't all shout the answer at me at once. Any ideas? Somebody at home got it. 45. Why would it be 45? Well, how about this? If those two sides are the same, notice if you had two of those triangles and put them together, you'd have a square, right? That fancy triangle is really, at the end of the day, just cutting a square with a diagonal and then taking the triangle out, and there it is. So it's got a 90 in this corner, and then these two angles here are 90-degree angles cut in half. So they're 45s. And they're 45. And remember how that means these two sides are the same. And remember how I told you yesterday that the idea that two triangles that are the same shape, regardless of size, are proportional. Some of you knew the fancy word similar. Well, that would mean that if I knew that I had, for example, I had a great big triangle out in the world. Again, maybe it was I was figuring out how tall a building was. And maybe King Kong was climbing it. That's the problem. I'm working for the SWAT team that's about to shoot King Kong, and I have to aim the cannon, so I have to figure out how high he is. So there we go. I realize that I'm aiming the cannon at 45 degrees that way, and all I have to know how tall he is well, just quick, figure out how far the distance is. Send the deputy with a tape measure running from the car to the building and hope that King Kong doesn't jump down and squash him. That's why you send the deputy. You don't do it yourself. And let's say that this is 100 meters. Well, then logically, this has to be 100 meters. And if this was 500 meters, this is the CN Tower now, apparently, then this would be 500 meters. Because I know that the ratio, let's use our fancy words from the other day. I know that the ratio from this angle of, what do you call that side again? Begins with an O. Opposite. I know that the opposite, and what do you call the one right next to it? Begins with an A. I know that the opposite to adjacent ratio is a proportion. It's proportionally the same. If this is 45 degrees, the opposite divided by the adjacent has to be 1, because I know it's an isosceles triangle. So if you tell me this adjacent line is 1,000, I know the opposite line is 1,000, etc., etc. But here's the thing. All triangles that are the same shape are proportional. So even though I wouldn't know exactly off the top of my head, what if instead of 45 degrees, what if it was like 44 degrees? Now, opposite divided by adjacent will have some sort of division ratio. It won't be quite 1, but now think about it. If let's say that I kept this line the same length in both of these triangles. So it's like the opposite, it's like it just dropped a little that way. So I guess technically, I kept the adjacent the same size too, but the opposite got a little smaller. If you look at this fraction, and this number at the bottom stayed the same, but the number on top here got a little smaller, well then the opposite divided by the adjacent would be just a little less than 1. And then if it dropped to 43 or 42, it'd get even less and less and less. But here's the thing. It wouldn't matter how big the triangle is, right? It'll be some decimal, 0.9 or something. But it'd be that same decimal no matter how big this triangle is, just like 1,000 divided by 1,000 is 1, 100 divided by 100 is 1. That proportion will be the same no matter how big the triangle is. I just kind of like need a list. I could do a list where it's like, okay, if my angle is 45 degrees, then opposite over adjacent is equal to 1. Okay, I'm going to look it up from my list. If it is 44 degrees, oh, there it is. If my theta is 44 degrees, I was right. Opposite, come on, pen. Opposite over adjacent is 0.9657. There, that's rounded to 4 places. Told you it was only a little less. And if it was 43, it's 0.93. What if it was way lower? What if it was 20? Oh, now it's 0.36. Now, some of you are noticing that I'm not looking this up in a book. In the days before scientific calculators were on your desk, you looked up these numbers from a booklet. But my scientific calculator has all these numbers programmed in. So I can look them up anytime I want to. They're called the tangent ratio. So go to that page and let's write some more notes. For angle A in this picture, which is the one up here, angle A. Okay, quickly let's label this the way we labeled it yesterday. That's side A, right? This is side C and that's side B. And for angle A, if I'm talking about angle A, if angle A is my angle of interest here, I'll put a theta on it. Then A is my opposite side. C is my adjacent side. And B is my hypotenuse. For angle A, the tangent of angle A, the word tangent is the name I give to the ratio of its opposite side divided by its adjacent side. So the tangent of angle A, and I don't usually bother with the angle symbol, and I don't bother writing up the whole word tangent. Tan's good enough. Tangent of angle A, and you know what? I'm also kind of tired of writing out the word opposite and adjacent. So I'll just go op over adj. And How many people have their scientific calculators in front of them right now? Can you find the button that says tan? Okay, now, can you make sure your calculator is in degrees? Ah, for those of you who have not perhaps used a scientific calculator for much before, I'm going to go to, okay, hang on, I want to go to the team meeting here. I'm going to just pause the video real quick that we're making. Oh wait, no I'm not, hang on. So, there we go, now we're back, and we go to, there we go. Okay, so guys, I just paused the video and turned on my document cam, or webcam, to show how to get into the right mode. I can actually show you on this calculator too. This is a very fancy calculator. This is fancier than most people's calculators. But if anybody is using a fancier calculator, you'll notice that if you go to mode sometimes, it'll say whether you're in, can you see that? Either radians or degrees. Now this calculator is in degrees. It's what I want. So I can quit the modes. If anybody is looking at a calculator and you can't tell whether you're in degrees or not, why don't you ask the calculator a simple question that'll tell you for sure if you're in degrees? Ask the calculator how much opposite divided by adjacent is for a 45-degree angle. You're looking at me like, what? Just ask it like, hey, calculator, no. How do you ask that question? You say tangent 45. What should it be? What is the ratio? It should be 1. If anybody punches those buttons and doesn't get a 1, let me know you're in the wrong mode and we'll try to fix you. Okay? So try that right now. You're not getting a 1? I can see from the wrinkle on your brow.
No, wait, what are you supposed to do?
Tangent 45 equals. Are you showing up without a calculator? I should have you slap. Okay, so yeah, on your calculator, yeah. Okay, if anybody's got a calculator like this one, or like this one, how do you square root numbers? You put them on the screen and then you hit the square root button, right? You've done that before?
Yeah.
Tangent's the same for you. You have to put the number on the screen and then hit tangent.
Okay.
There we go. So what we've discovered, here I am walking away from the microphone as I make a video. Professional work I do here, right? Okay, so what we've discovered with people in the room is there's kind of 2 different ways calculators work. If you have the kind of calculator where if you wanted to square root a number, you have to type it on the screen and then hit square root, tangent's going to work the same way. Put the number 45 on the screen and then hit tan. It should spit out a 1 if you're in degree mode. Is there anybody who isn't getting a 1 no matter how hard they try? And that goes for you at home. I hope you at home got your calculators out and you're playing along. You're not just sitting there in your underwear scratching your butt. You got to be working at home there. Come on. We good? Everybody's getting a tan of 1? Tangent of 45 is 1? Okay, cool. We're ready to actually solve some problems with tangent then. First of all, what would the ratio be for... Oh, hang on. I went too far. Let's look at example 1a. Now, I added something to example 1a. It says, sorry, I added something to example 1. I added the a. Can you add an a to it the way I just did? Determine the ratio for tangent of x and tangent of y. And then leave your answers in fractional form. But then I added something to it. I added a part b that says, find the measures of angle x and angle z. There we go. So that's what we're going to do. We're going to take this to another level. Can you please add that? Write down what I wrote. Okay, we can answer the A question without punching any buttons because we just want the ratio. If angle X was 45 degrees, those 2 sides would be the same. Right now it's 18 and 7 instead of 18 and 18 or 7 and 7. So it's definitely not 45 degrees. We'll find out how much it is in a second. But the tangent of angle X is, here I'm just going to write the answer, see if you can figure out how I got it. The tangent of angle X, make sure that's a big capital letter, right? Angles are capital letters, is 18 over 7. So there we go. That's the ratio, and I left it as a fraction. Mr. Kello, should I make that a mixed number? No, please don't make it a mixed number. We actually like improper fractions better than mixed numbers in almost every branch of math except like cooking recipes. I dare you to find me a recipe that says go add 3/2 of a cup of flour. Right? It'll say 1 1/2, right? Oh, and I guess interest rates too, right? Right? Today's interest rate is 1 3/4. It'll never say 7/4. Beyond those two things, every other place in life, improper fractions are far more efficient than mixed numbers. So, what's the tangent of y? Or sorry, I meant to say tangent of z. What's the tangent of z now? It's 7/18. How come they're different? And where did I get those numbers from? Well, remember we said, I'll write it up here again, that the tangent of some angle is its opposite divided by its adjacent. So notice for angle x up here, I'm going to use the highlighter, this is the opposite, and this is the adjacent. But, let me back up now. If I'm talking about angle z, this is the opposite, and this is the adjacent. Right? Logically, they switch, because you're talking about a different angle now. Is that cool? All right. Now let's do the B part of the question. I would like to find the measures of angle x and angle z. So I'm going to actually, I'll do them one at a time here. Okay, pen, come on, there we go. So let's start with the first one. Tangent of angle x is equal to, that should be a capital X, big X, is equal to 18/7. How do I figure out how big angle x is? I ask the calculator the opposite question that we asked it a minute ago. A minute ago, we asked our calculators, we said, hey, calculator, how big is the ratio for a 45-degree angle? Well, now we're going to ask the opposite. We're going to say, hey, calculator, I got this ratio. It's 18/7. How big is the angle? So we're going to do the opposite of tangent. That sounds really bizarre, but you've been doing this for years. Don't write this part down. Grade 7 algebra. Quick, how do you solve that equation? What do? You minus 7 from both sides. Why do you do that? Because it's the opposite of adding, right? So if I want to get rid of this add, I got to subtract. How do you solve this equation? You divide because it's the opposite of multiply. Ooh, this one's a little bit harder. How do you solve for that x? You square root because it's the opposite of squaring. With that in mind, this is an equation. I need to do the opposite of tangenting. Tangenting's not a word. I made that up. You have to do the opposite of asking the calculator, hey, what's the ratio? I got the ratio. I want to ask the calculator, hey, what's the angle? Here's what you actually type in. Can you look at your calculator really closely? Finally, something that's the same on every calculator that was ever made. Tangent to the -1 is the same button as tangent. You just have to hit shift. So I'm going to do this. I've got the kind of calculator like my friend who asked me how their calculator worked a minute ago. I'm going to take 18 divided by 7, maybe even hit equals, then go shift or second function, whichever your button says, and then tangent. Then if I'm going to use my calculator like my other guys in class have, I'm going to go second function tangent first, and then I'm going to open a bracket. What? Brackets? Yeah, open a bracket. And go 18 divided by 7, close the bracket, and hit equals. Then if I've got a really fancy calculator, like this blue one here, I don't even have to open the bracket myself. It opens one for me. Inverse tangent. Anybody else have now a tan -1 and it opened a bracket for them? A couple of people are nodding yes. Very nice. See if it'll make you a drink and everything too. It's a very helpful calculator. My calculator Jeeves here. Fetch me my slippers calculator. And there we go. Inverse tan and get the answer. And all of us should have that angle x is, let's round it to one place, 68.7 degrees. Is there anybody who didn't get that number? Yes, person at home who said tan inverse, you can call it inverse tan. This -1 is an unfortunate symbol that we use in math because, you know, -1 as an exponent is something you can do. You can do exponents that are -1, but it's actually not an exponent. It's just a symbol. Just like when I use the symbol pi, I'm not reciting the Greek alphabet or baking a pie like it's a recipe. I'm just using that symbol to represent a number. I am using that symbol of -1 to represent inverse, as the person in the chat said, inverse. Some people even call it arctan, which is just a fancy way of saying the opposite of tan. Okay, we said we were going to find them both. Erase all this. Okay, I'm kind of out of room. Hopefully you can write smaller. So what was the equation again? It was the tangent of y is 7 over 18. And I drew that really ugly. Let me fix that. 7 over 18. That's much better. Okay, can you try that again? So what kind of hold up your calculator. Oh, is it because you don't know what buttons to punch? Oh, thank you. Z. Thank you for being more awake than me. Okay, so if you were able to do it yourself the first time, try it again. Angle Z is equal to the opposite of tangent of 7/18. Now, some people might actually want to put the decimal down. You could. If you put in another step, I'm happy to see it. You don't have to show me this step if you don't want to. But if you wanted to, you could actually write down, oh, the tangent of Z is, what is 7/18? Oh, you'd think I should know that fraction off the top of my head. Oh yeah, of course, it's 0.38 repeating. Should have known. There we go. And then you can do Z equals the inverse tangent of the decimal. I don't really care if you write those steps down or not. Work in decimals, work in fractions, they both work for me. Either way, your final answer, come on, pen, your final answer should be 21 point, I'll round it to one place, 21.3 degrees. And then, hey, what do you notice about our two answers that totally makes sense when you think about it? They add up to 90, which they should, right? Because the third angle in the triangle is 90. And so, ooh, there's a fancy word for that. Anybody knows what it is? It begins with a C. No? They're called complementary angles. They add up to 90. Supplementary means they add up to 180. Yours not working?
No, I didn't get that.
Okay, try going 7 divided by 18 and hit equals. Do you get 0.38 repeating?
No.
Inverse tangent.
I got 0.006.
You're not hitting inverse or second function properly. Or are you accidentally not in degrees anymore? Does it still got a little D on the screen?
I got it.
There you go. Okay. Anybody at home having troubles punching buttons? Okay. Next. What if it's the other way around? What if we know the angle, but we want to find out how long a side is? So, I would like to determine the length of side Z in this triangle. Well, first of all, which one's side Z? Is it the height or the hypotenuse? It's the height. So this is side Z. Okay, now I am going to use my tangent ratio. And I know that the tangent of any angle I want, any angle of course being theta, is equal to its opposite divided by its adjacent. All right, what do I know? I know the angle. It's 38 degrees. What's the opposite here? The Z. I don't know that yet. That's what I'm looking for. What's the adjacent? 7. Now, how do I get Z by itself? What do I do to isolate it? Basic algebra. Times both sides of this equation by 7. So Z is going to equal 7 times the tangent of 38. Z equals, try punching button, see if you get it. This time you don't need that second function. This time we're going forwards. We know the angle, we're looking for the ratio. So 7 times, in my case on this calculator I have to put 38, hit tangent, and then hit equals. If I was using my fancier calculator, I would just go 7 times tangent of 38. Either way, I get, it says 2 decimal places, always do what it says, 5.47. It doesn't have centimeters or meters, so don't put a unit on it. If the question has units, your answer had better have units. But there we have it. Anybody not get 5.468999386 blah blah blah? Anybody not getting the right thing when they punch buttons? Okay. There we go. We've just used tangent to solve for a missing side in a triangle. And we use tangent to find a missing angle in a triangle. There's kind of only one type of problem we haven't really tried yet. What if the missing side is the adjacent side? Find side W. Which one's side W? This guy. The tangent of any angle is the opposite over the adjacent. I'm going to write this formula a million times until I remember it forever. So write that down. Okay, but I don't have to call it angle theta. I know what angle it is. It's 65 degrees. And I don't have to call it the opposite side. Which of these two things is opposite to 65 degrees? The bottom one, the one where I know the number, 26.5. The adjacent side this time, this one's the opposite, this one's the adjacent. That one's my W. Ah, who remembers the little trick? Who's my non-algebra fans out there? I gave you a trick for how to solve these yesterday. Remember that? Remember I told you that solving for fractions is going to be really important this unit? The last one was T for top, T for times. This one is D for denominator, D for, this is a divide. What actually happens is the tan of 65 and the W switch spots. Well, that's not really true. You know what really happens? I times both sides of the equation by W, and then I divide both sides of the equation by tan 65. But that's a lot of work when all that happens is this. Now don't get fooled by your own calculator. I'm gonna fool myself with my calculator. Watch me carefully. Guys at home, pretend you're watching me carefully. I type in 26.5. I go divide 65 tan. Oh, my screen changed. The answer is 2.1. No, it isn't. What have I not done yet? I haven't hit equals. You know what the 2.1 is? It's the ratio for the 65 degree angle. It's the opposite over the adjacent. But that's not my answer. My answer doesn't happen until I hit equals, until I do the divide. So W is equal to 12 point, let's see, how many places? 2 decimal places? The thing after the 5 is a 6, so 12.3, or sorry, the thing after the 5 is a 7, so 12.36. Oh, this time, if I left it like that, I've lost half a mark. What did I forget this time? Centimeters. See, the last one didn't say what it was measured in. This one's got centimeters, so the answer had better be centimeters. All right. Guys at home, I'm kind of keeping my eye on the chat there. Is there anybody who's having calculator issues plugging these in, not seeing how the buttons are working? Okay. If you absolutely have to try punching these on your phone, you can, but get a calculator. I'm not letting you use your phone on a test. Okay? And don't buy an expensive one. A cheap one will do. In fact, I've seen students goof them up with the expensive calculators. Let me just roll back for a second here and point something out to you. Those of you with your fancy calculators, like you've got it all in life because you've got a fancy calculator. Should it matter if I type this in? You don't have to write this down. Apparently I don't have to write it down either. My pen's not working. There we go. Should it matter if I typed it in as tangent of 38 times 7? No. You should be able to type two numbers in any order you want, right? 2 times 3 and 3 times 2 are both 6. But if you've got one of these calculators that opens the bracket for you, a couple of you, we talked about this, if I type in tan 38, and then I forget to close that bracket, and then I go times 7. Now it thinks I want the tangent. What's 38 times 7? 200 and it thinks I want the tangent of a 268 degree angle. Good luck making me a triangle with a 268 degree angle in it. But you know what? Oddly enough, it will give you an answer. Why does it give me an answer? What kind of right triangles have a 268 degree angle in it? That's beyond obtuse, man. Well, you'll actually learn in grade 11 that you can do trigonometry in triangles that don't even exist as triangles. But this is clear. It's a negative number. It's like, oh, nice. That line is negative 1.7 long. So when I see goofy numbers like that, I know this is a person who is having some issues understanding their calculator. Don't forget, those of you with a fancy calculator, if you typed it in this way, your calculator opens a bracket for you. Close it before you times the 7. Okay? All right. That is all there is to this tangent stuff. We've got a couple of problems we can do as practice, but okay, you guys at home, I'm going to put a few tangent questions from your textbook for you to practice for your homework tomorrow. No, you don't just get to sit there and study an extra day for the test. That's not fair. So you guys are going to do some tangent homework tomorrow while the other group does the test. And then on Friday, they get to do the homework while you do the test. And then we'll pick it up and learn how to do the other trig functions on Monday. Yep. You want me to go backwards? Okay, let me close my video off first. Let me shut the video down and start encoding it here. Give me just 2 seconds and I'll answer your question, okay? Recording over.